All right, Chapter 8, Problem 28. Here we have a one-dimensional problem. One-dimensional means it's all happening along a line, right? So a billiard ball comes in, collides with a second one. The first one comes to a stop, and the second one takes off with the same velocity that the first one had, right? What does this mean? Show that both momentum and kinetic energy are conserved. All right, so what's the momentum beforehand? Momentum beforehand is mass, I'm going to call them 1 v1, right, plus m2 v2. Well, this ends up just being, since they both have the same mass, v2, the velocity of the one sitting still, is 0, so this is mem times the initial velocity, right? Now, what's the final velocity? Well, is m1 v prime 1 plus m2 v prime 2, the prime to indicate that this is after the collision. It may not be exactly the same, but the problem says after the collision, the first one has come to a stop, so v1 is 0. The second one is now moving with the exact same velocity the first one had when it hit it, so this is mv, and so this shows us, since the initial momentum is mv and the final momentum is mv, that momentum is conserved. All right, kinetic energy. Initial kinetic energy is 1/2 mv squared, right? It's just the kinetic energy of the one that is moving. And the final kinetic energy is also 1/2 mv squared, right? It's just the kinetic energy of the one that's moving. The one that came to a stop now has 0 kinetic energy. The one that started moving now has energy of 1/2 mv squared. The final and the initial kinetic energy are both the same, and so kinetic energy is conserved in this collision as well. And that's it for problem 28.